A320 APU system from FCOM. So let's start the APU system. But before starting, disclaimer, I do not own any of the image and content used in this course. All of this is a reproduction of Airbus manuals. Do not use this information in your practical life. I do not recommend. If in case you find me wrong, if my explanation is not up to the point, please let me know in the comment, as I am also like you guys, I am also studying A320 right now. And the most important thing, I will be shooting this video in a raw mode, so there will be no cut in the videos, so there are chances of slip of tongue or any misinformation. Please let me know in the comments. I am open to all. So let's start APU system. So we will be studying APU from FCOM. We will go to the systems, and then 49 is APU. So we will study from my notes. APU systems, aircraft system, APU. Next, the very next slide in FCOM is the description of APU, what all we will study in APU. So we will discuss about ECB, electronic control box. We will discuss air intake system, how the air is taken from outside to the APU, then how the starter works, then how the fuel is supplied to the APU, then oil system, then IGVs, then air bleed system, how APU provides bleed to the aircraft, and then further ground operation safety device, and then in the end controls and indications. So let's start. There are, it's a very small chapter, there are hardly 10 to 15 pages, or if I'll double it, then there are only 20 pages in FCOM. It's a very small chapter. Video, you can watch this video at 1.5 or 2x according as appropriate, according to your pace. So what is APU? APU is auxiliary power unit. It's a self-contained unit that supplies the aircraft pneumatic and electrical power. So it is in the tail of the aircraft. You all know it is in the tail of the aircraft. What are the functions of APU? What does it does on ground during takeoff and in flight? So let's discuss it. It supplies bleed air for starting the engines and for air conditioning systems. It aids. It supplies electrical power to the whole electrical system of of the aircraft. During takeoff, it supplies bleed air for the air conditioning system. In some airlines, company procedure, according to their company procedure, they keep APU on, but in some airlines they do not use APU for takeoff. It is used just to provide air conditioning from APU, not from the engines. But in generally, if we do not use APU, then airlines recommend their pilots to switch off the packs and then take off with packs off. But in some airlines, they use APU for air conditioning specifically during the takeoff phase. What does APU do in flight? So it backups the electrical system. We have two main generators, but it backups the electrical system in case of any emergency. It backups the air conditioning system. So we have our AC packs connected to both engines separately, but it backups the air conditioning, electrical, and it can be used to start the engines. So there are some limitations which you can uh, go to the limitation section of FCOM and you can read the APU's limitation. I have jotted down here. So the maximum altitude a APU can assist a engine start is 20,000 feet. A APU can start a engine at or below 20,000 feet. If you want to use APU for air conditioning, then for single pack APU can provide can be used till 22,500 feet and below. If you want to use two packs, both AC packs, then you can use at or below 15,000 feet. And for electrical supply, APU can be used till 41,000 feet. So and one more thing is you can start a APU with batteries at or below 25,000 feet. So here are some limitations of APU I have written. APU batteries can support APU start at or below 25,000 feet. This is all written here in this page of FCOM. So what do you need to for running operations of APU? Sometimes the question can be asked. So you need DC bat bus to be powered. So if DC bat bus is powered, then only you can use APU. Is it clear? Right. Great. So this is APU's diagram. Let me do it. Okay, so here is the aircraft and this is APU, right? So this is your air intake. This is your air intake. This is flap motor and this is flap which closes and opens. Then this is IGV. This is IGV. This is load compressor. We have only one compressor. This is turbine. This is turbine. This is turbine. Then we have surge control valve here. We will discuss about it. And we have APU bleed valve. This is automatic and we can control APU bleed valve from the cockpit. Is it clear? Right. So we have a gearbox. As in engines we have accessory gearbox where all accessories are mounted. Right. This is combustion chamber. This is combustion chamber. Right. Now the next slide. As I told you, we will discuss about electronic control box, then how air is taken, then how starter works, then fuel supply, then oil system, then IGVs, then ground operation safety devices we have for APU. So let's start from this. So APU is a single shaft gas turbine that delivers mechanical shaft power for driving the accessory gearbox. It is very clear from here. It is single shaft. It is single shaft. and gearbox is connected to provide electrical energy and produce bleed air for engine starting and for pneumatics supply, obviously. Now, what is ECB, electronic control box? ECB is similar to FEDEC, which is full authority digital electronic controller, which is used in generators, to main generators. So in APU we have ECB. What does ECB do? It controls everything like FEDEC does in engines, to the main generators basically. So it monitors bleed air. There are a lot of questions that bleed air is controlled by, bleed air of APU is controlled by ECB, not the FEDEC, and not any other computer used for bleed monitoring and bleed supply. What else ECB does? It sequences the start of APU and it monitors it. It sequences the shutdown. It monitors speed and temperature and obviously monitors the bleed air. Now, air intake system. This is air intake system. This is air intake system. We have a flap motor which opens and closes this gate. Okay. The air intake and an electrically operated flap allows external air to reach the compressor inlet, obviously. Starter. The ECB controls the electric starter. Once you press start push button, then after 3 seconds the engine starts, basically APU starts, in air starter engages. So where are these buttons? Here these are. This is your A320 cockpit. You'll look here, this is APU in the center. We have APU master switch and we have APU start switch. These are the switches they are talking about. Once you press master switch, it allows it provides the electrical supply to the APU, and then when you press the start push button, then after 3 seconds starter engages. I have written 3 seconds here because it has been asked in so many questions, airline interviews. Now fuel system. How APU is how fuel is supplied to APU. So APU, the fuel is supplied from the left hand tank. Keep it in mind, left fuel feed line supplies the APU. If the pressure is not enough and the pressure is not available, then we have a separate APU fuel pump that automatically starts. The same is written here in the FCOM. And the fuel pump is totally automatic and ECB controls the fuel flow. So where is this fuel pump and how does it work? I have taken a screenshot from fuel system. I have taken a screenshot from fuel system. Now you can see here. Let me take pen. Okay. So this is cross feed valve, right? These left hand tank feed line supplies fuel to the APU, and this is APU pump. In normal conditions, in normal situation, this pump remains off and fuel is supplied to the APU by the pressure, by the pressure of these pump. But If in case pressure is low, then this fuel pump, this is APU fuel pump, this starts automatically, creates pressure and sucks the fuel, right? Clear? This schematic diagrams clears your two doubts, that fuel to the APU is supplied from the left tank, and we have a APU, separate APU pump. In case of low pressure, it starts automatically, and ECB controls the fuel flow. Very important. There are no switch for APU fuel pump, for this fuel pump. For other pumps we have, for these pumps, wing tank pumps and center tank pumps, we have controls in cockpit, but for APU pump we do not have. Let me show you. So here, fuel, we have, you can see here, left hand, let's start from the left hand tank pump 1 2, we have center pump 1, this is mode selector, this is something different, pump 2, right hand tank pump, and pump 2, pump 1 and pump 2, that's it, right? So back to fuel system. Now fuel system is clear. Oil system. APU has an integral independent lubricating system, its own lubricating system as engines have. You can watch my videos on engines, it will be clear there. We have IGVs, inlet guide vanes. What does IGV does? IGV controls the airflow, bleed airflow to the compressor, right? And they also controls the fuel pressure powered actuators. They controls the position of IGVs. So where are these? These are IGVs. These are IGVs, and they controls the bleed airflow to the compressor, right? It's very much clear by this diagram, right? Now we have air bleed system. This is important, and I have seen a few questions from this topic, this point. The air bleed system is fully automatic. APU bleed has priority over engine bleed system. In normal conditions, APU run at 100% of its capacity to supply the demand. If the temperature is between minus 18 degrees Celsius to 35 degrees Celsius, plus 35 degrees Celsius, it's an ambient, it's a normal temperature, and if this requirement is met, then ECB commands APU to run at only 99% of its actual value. No need to run at higher RPMs, right? This is a temperature where demands can be met easily. Air is dense, you know. For all other temperature except this range, APU runs at 100%. Air bleed is done. Now controls. Where we have controls of APU. In normal conditions, to start and shut down, we have a panel on overhead, lower overhead panel. I have shown it to you. Again I am showing it. This is APU panel. We have two switches in it. We have few other panels also to shut down the APU. In case of emergency, we can use APU fire handle. You know where APU fire handle is? It's in between the two main engine fire handles, and we have a third panel also, which is on the nose wheel, which is on the nose fuselage, under the nose fuselage. Let me show you. I have it is shown in the further slides. So near the nose wheel we have this panel, right? This is called, the technical term is 108 VU panel. This is external power panel, and we have a switch, guarded switch, which is APU shutdown. There is a button called, in case of APU fire, uh, ground personnel can use this button, for APU fire button, to switch off, to shut down, emergency shut down the APU, right? Very clear. Now we have gone through all three panels, all three controls of APU, right? What are ground operation safety devices? In case of fire, what safety devices we have in our aircraft? This is what it means. So we have APU fire warning in the cockpit. It's oral warning. There are visual warnings also. There is a horn in the nose gear base at near 108 VU panel. I have shown you before. The avail light goes out. Avail light from this switch. This switch goes off, and the fault light in the master switch lights up, right? Clear. So these are the safety devices, safety measures we have in case of any emergency, in case of fire or something. APU shuts down automatically if aircraft is on ground, and APU fire extinguisher discharges automatically, right? So these were the slides till here. Here your APU system from FCOM completes. Now there are controls and indicators, right? So the whole system is in 4 or 5 slides. This is very small chapters, right? Right? Now we will study controls and indicators. This is APU panel in the cockpit. We have master switch. We have start push button. What does master switch do? It supplies electrical power for APU operations and its protective features, right? It also controls the starting and shutdown sequence. This master switch. We are talking about master switch. If there is no light on it, it means APU is off, and if there is this on light on it, it means APU is in starting sequence. If this on light is there, it means APU is in starting sequence or APU is operating. We are talking about this master switch and its light, not about the start switch. On start switch we have avail light and on light, right? What else do we have in this? Anything important? Yes, these lines are important. During manual shutdown, if the on light on the master switch push button and avail light on start push button goes off, and you switch it off, then APU, and aircraft is using APU bleed air, then APU keeps running for 60 to 120 seconds, 60 to 120 seconds if aircraft was using APU bleed air, right? This is important. Okay, nothing important from this slide. Now talking about the same master switch, when does this fault light on this master switch comes, this fault light comes? So there are few reasons when aircraft uh, or this APU's automatic shutdown occurs. Whenever there is an overspeed, when there is no acceleration, or there is a slow start, there is no flame or reverse flow, low oil pressure, overcurrent, sensor failure, IGV failure, obviously ECB failure, no speed, when APU is running under speed, loss of overspeed protection, even there is a loss of overspeed protection, then also this spotlight comes. There is a number of reasons. There are a number of reasons this fault light can come. So you can read it one by one. Now we will talk about the start push button. There are two sections. On the upper section we have operational information, which is avail light, and on the lower section we have on light. When APU is off, there will be no light on this panel, but if there is on light or avail light on this panel, and what does it mean? When do they come? When, let's talk about avail light first. If there is avail light on the start push button, it comes when N is rotating above 95% of its RPM and APU is started and can supply bleed air and electrical power to the system, then this avail light comes. It means APU is available for use. It only comes above 95% of N. Remember it. When does this on light comes? This on light comes when starting sequence is in progress. Then this on light comes. So first of all, when you press this button, on light comes. This on light comes. Correction. I'm right. This on light comes. It means that APU start sequence is in progress. After that, when N is above 95%, then on light goes off and avail light comes. Then now APU is available for electrical use or for bleed use. So there are few important digits. When N reaches 95% or when N is above 99.5%, when after 2 seconds, when N reaches 95% or when N is above 99.5%, the N light on the start push button goes off and avail light comes, and 10 seconds the APU, and after 10 seconds the APU ECAM page, there will be always a page on APU page on ECAM when you will press this push button. So after 10 seconds this APU page from ECAM will disappear, right? These are some important timings you have to remember. right? Nothing else from this. Everything is covered from this slide, right? Now I have told you about this 108 VU panel. Yeah, it is near the nose wheel, right? Next, and the second last slide of APU is ECAM APU page. This is the page they were talking about in last slide, which disappears after 10 seconds when n has reached 95%, right? The only important number I would tell you is this. This is the limitation of APU. The maximum the APU can run at n greater correction till n 107%. This is the maximum RPM. This arc here, this n becomes amber. This n becomes amber if n is greater than 102%. When it is greater than 107%, then greater than or equals to, basically, then it becomes red. Otherwise this is displayed in green color, right? Here this is APU gen line connector. It is displayed in green color whenever it is closed, right? This avail light, we have talked about it when n is above 95%, you remember, right? So, and this is APU bleed valve position, right? This is bleed valve position. This is let me clear it. This is APU bleed air pressure. These are warnings. It means flap is open, inlet flap is open, fuel low pressure. It's showing fuel low pressure. It is displayed in amber color, right? That is it. That's it from it. This is EGT limit. Now we will discuss about EGT limitations of it in further slides. What are the EGT limitations for APU? So when you are starting a APU and you are below 35,000 feet, your maximum EGT here should not exceed 1090 degrees Celsius. It is important limitation. When you are above 35,000 feet, it should not exceed 1120 degrees Celsius. Keep it in mind when APU starts completely, this maximum EGT drops down to 675 maximum. Remember it. But in case of limitations, maximum EGT limitations of engine, it is opposite. In the beginning it is less, and during operations it is, the value is more than the beginning, the initial value, right? And that's it. Please keep it in mind. These are the limitations. Maximum EGT during start below 35,000 feet and above 35,000 feet, and maximum EGT limit for APU running, with APU running, is 675 degrees Celsius. There is APU avail memo display also. When does it come? APU avail. It comes in green when N is above 99.5% or it has been 2 seconds when N has reached 95%. It depends on the configuration. It is written, we have studied it here also. As I told you, these lines are very important here. Mark them, write them down and keep revising them. 10 second APU page disappears, 2 second when N reaches 95% or when N is above 99.5%, on light goes off. You can read them, reasons of automatic shutdown, right? And keep them in mind. Chapter is over now. You can leave if you want. I'm just telling you what else, whatever was important, the most important thing. Keep revising these EGT limitations, right? Then let's start from the beginning. Please, I request you, please remember these values. Maximum altitude to engine start, single pack operations, dual pack operations, and at till what altitude batteries can help to start APU. Okay, and in the end, DC bat bus is required to be powered, must be powered for running operations of APU, right? Keep it in mind. Next in this slide, yes, ECB controls the bleed monitoring system, right? ECB controls the bleed monitoring systems of APU, not the FADEC. We have talked about air inlet starter. After 3 seconds of pressing start push button, then the starter engages. Then fuel supply, left fuel feed, APU fuel pump automatically start, no pressure. This was important. Then this APU bleed system, these values, three panels. Then this is, yes, it's very important. If aircraft was using APU bleed air and you manually switch this button off, then APU keeps running for cooling for 60 to 120 seconds, and at 7% the air inlet flap closes. You know what inlet flap they are talking about? Yes, at 7%, right? That's it from this slide. I'm just telling you the important stuff from the whole APU chapter. We have covered it, right? So that's it, guys. Thank you very much for watching this video. Again, I'm telling you, I'm not a teacher, I'm not a YouTuber, so please do not expect me to be very proficient in teaching and a pro editor. If you are thinking, please, I'm not a YouTuber at all. Thank you very much. Good day.